guys, and welcome back to This Week in STEM. This is going to be a short one because I am sick as a dog and I just want to go back to bed. The first story of the week hits me right in the nostalgia feels because it's got to do with Mario Brothers. For those of you that don't know, there used to be this thing called the Nintendo Entertainment System way back in the day, like the 90s. Oh, I'm getting so old. On this system, I used to play it for hours, playing Mario Brothers, Duck Hunt. You know you always shout at the dog. Don't even play. This week, PBS's Spacetime is trying to ruin my childhood by saying that the game is not scientifically accurate. My response is, what was your first clue?
Was it the things called Goombas, the turtle-looking Koopa Troopas, or maybe the talking toadstool sporting an Aladdin vest telling you that the princess was always in another castle?
The good people over at Spacetime were trying to figure out what kind of planet Mario and Luigi's world existed on.
Based on what we can see from the video game, it's probably a rocky planet with an atmosphere similar to that of Earth.
The problem arose when they tried to calculate the gravity for this world. Now in the game, Mario can jump super high, super fast, implying that it's a low gravity world. However, if this was a low gravity planet, as implied by Mario's very quick, very high jumping, then you would anticipate him descending at a very slow rate, much like the astronauts do when they bound along the surface of the moon. But for anybody that's played the game, you know this isn't the case. Mario comes back down at a very fast rate towards the surface of the planet. Using this equation, you can calculate the acceleration due to gravity.
Now in this equation, s is equal to the distance that Mario will fall back to Earth, s sub 0 is his starting point, which can be assumed to be equal to 0, v sub 0 is his initial velocity, which can also be assumed to be equal to 0, a is his acceleration due to gravity, and t is the time it takes him to fall back to Earth.
Now if you take into account the variables that I just zeroed out and solve for a, you can come up with this.
This simplified equation can be used to calculate the acceleration due to gravity for Mario's homeworld.
Mario's jumps and falls vary throughout the different games, so for this instance, we'll focus on only 1990 Super Mario Brothers, which is what PBS Spacetime focused on. Now, in this game, Mario jumped about 2¼ times his own height, and it took him about 1/3 of a second to fall back to the ground. Now, taking these known variables, you can plug them into that equation that we just came up with to determine the acceleration due to gravity. Now, Earth's acceleration due to gravity is about 9.8 meters per second squared, or 32 feet per second squared. However, when you plug in Mario's numbers, you get an acceleration due to gravity about 8 times that of Earth, meaning that the gravity is 8 times stronger, or 8 Gs. Now, to put this into perspective, humans pass out after about 5 Gs. So assuming Mario hasn't been skipping leg day at the gym, could this world hypothetically exist? Well, based on what we know about planets forming, scientists say no. When you look at our own solar system, Jupiter, the biggest planet in the solar system by far, has only a gravity of about 2.5 times that of Earth. Additionally, it's a gas giant with no discernible surface, so Mario would have nothing to run around on to begin with. Even using data from Kepler, which looks outside of our own solar system for other planets, the largest one that we know about is only about 4 Gs. So based on what we know, Mario's world probably doesn't exist in real life, which is fine because those guys are some really shoddy plumbers and Goombas really creep me out. The next story of the week is something I'm sure everybody's heard about. That's right, we're talking about the dress. If you haven't heard about the dress, then I have to ask, how is the feng shui below that rock which you are living under? Because everybody and their brother knew about this thing. It divided families and the engineering department where I worked.
So this is the dress that's been causing World War III. Some people see it as black and blue, and some people see it as white and gold.
So why do we see the dress differently? When light enters your eye, it enters through the lens and strikes the retina on the back of your eye, where there are rods and cones. Now cones are more sensitive to color and rods are more sensitive to light. So if you're seeing in the dark, you're seeing with more rods. Different people have different ratios of rods and cones, which could be leading to the different perceptions of color. Now the image is processed in the visual cortex part of your brain. In your visual cortex, your brain takes out colors that it thinks of as extra. For example, if you're looking at something in the dark, your brain understands that the object is probably a little bit brighter than what you're seeing, so it may subtract some darkness to lighten the image for you. In this image, the theory is that the lighting, combined with the really crappy Instagram filter, is just ambiguous enough to throw people's perceptions off. So some people see it as white and gold, in which case all of the light is reflected back, so you see white light, and in my case, you see black and blue, which is the actual colors of the dress. So to settle this once and for all, here is the actual dress. Team black and blue, team black and blue, team black and blue. Good, now that that's settled, can we go back to talking about the really important things like free the llamas? And now for the final story of the week, which will have Vin Diesel writing the next pitch for the 63rd Fast and Furious film. Is that what we're on now? I don't know, I'll still watch them. I'm a sucker for cheesy action films. I love them so much, so much. This news comes out of the Google Lunar X Prize competition.
The Google Lunar X Prize competition is a $30 million competition consisting of 16 teams building rovers that will race on the moon.
That's right, on the moon, giving a whole new definition to the term space race. At a news conference in Tokyo on Monday, the two frontrunners, Astrobotic out of the United States and Hakuto from Japan, announced plans to fly together to the moon in 2016. Now here's the plan as it stands today. Astrobotic from Carnegie Mellon University and Hakuto from Tokyo University, along with any other of the 16 competitors that will sign on, will fly to the moon on a SpaceX Falcon 9 rocket. Once there, the rovers will descend to the lunar surface on board Griffin, Astrobotic's lunar lander, that looks a little something like this.
Griffin's descent to the lunar surface will be autonomous, using software developed by Carnegie Mellon University, a pair of stereo cameras, and a range-finding laser.
Once on the lunar surface, Andy, Astrobotic's rover, will deploy first using breakaway bolts.
Andy, seen here, will then roll on over and play rover paparazzi, while the rest of the rovers, including Hakuto's Tetris and Moonraker rovers, descend using ramps or whatever other form of deployment that they have chosen.
Now, once all the other rovers are deployed, they'll roll around, do their checkouts, power on to make sure everything's working hunky-dory, and then line up for the race. While the comparison has been made, Formula One it is not. These rovers will have to roll around incredibly slowly just to make sure that they don't land in a lunar pothole or get stuck somewhere. The first rover to roll its 500 meters and beam its video back down to Earth will take home the title of coolest robot ever and bring its team $20 million worth of that grand prize money. The race itself is supposed to be streamed live, so look out for that coming in 2016. Move over, NASCAR, you got nothing on rover races. So that's it, guys. I know it was a short one, but I feel like death warmed over. I am sick as a dog, and I'm gonna go curl up, put on my pajamas, and watch the rest of House of Cards, or pass out for the night, well, whichever happens first. Don't forget, if you've got any really cool STEM-related stories that you want me to cover in next week's Twice In video, don't forget to tweet them at me or send them to me on one of my other social media platforms. I'll include links to those down below. And with that, I invite you to boldly go, have a wonderful week, and spend time with someone who is and will always be your friend. Now, in this game, why? Okay. Oh. I'm not gonna pass out or throw up on camera. I'm not gonna pass out or pass up. I'm not gonna pass out or throw up on camera. I'm not gonna pass out or throw up on camera. This news. This news. I said it again. Carnegie. Okay. Once there, they'll descend to the lunar. Once there, they'll descend to the lunar surface using Griffin, not Andy. Andy Griffin. You should have named it Andy Griffith. Major opportunity lost. Andy Griffin. I should have named it Andy Griffin. Sudden realization that Astrobotic should have named it Andy and Griffith, but whatever. I'm not gonna judge you on totally disregarding an awesome TV show. Team Black and Blue, Team Black and Blue, Team Black and Blue, for the win.